In this video, I will show you how to use molarity to solve stoichiometry problems. So, in the previous video, I talked a little bit about molarity and the other units of concentration. So, let's just review molarity. Molarity is represented by a capital M, and it is equal to the moles of solute over 1 liter of solution. This 1 liter of solution will never change. You won't have 2 liters. What will change is the number of moles. So keep that in mind. Knowing that is a very useful unit conversion factor. One more thing you have to know about molarity is that these two things you can call molar. You can just represent by an M. So you will say 0.15 molar, which would represent 0.15 moles per liters, or 1 liter. You don't really have to write the one. So let's solve a stoichiometry problem using molarity as the conversion factor. So the problem says you have 0.1 grams of magnesium hydroxide, is written as MgOH and 2 here. So that magnesium hydroxide is treated with 0.1 more HCl or hydrogen chloride. 0.1, let's put it at 0.10 more, just to be able to tell the difference between these two, of hydrogen chloride. So what they're asking is how many milliliters of hydrogen chloride will react. So milliliters of HCl. Now, as in any chemical stoichiometry problem that you have, you want to start by writing the chemical reaction or the equation. So let's do that first. It says that this is treated with this, so it would be magnesium hydroxide plus hydrogen chloride. That would form, this is a double replacement reaction, so the magnesium reacts with the chlorine, MgCl2, and then hydrogen and hydroxide will form water. But you have to balance the equation. Make sure to always balance it to get the correct mole ratio. So we have one magnesium here, one magnesium here, then one chlorine here, two chlorines here. So we add a 2 here. I'm going to write it with red so you can take a different. And then we go for the hydrogen. We have 2 hydrogens here, plus 2 hydrogens is 4 hydrogens, and 2 hydrogens in this side. So we multiply this by 2. And finally, we count the oxygens. We have 2 oxygens here, and 2 times 1, 2 oxygens here too. So this equation is balanced. So if you remember the mole diagram, let me put it up. So this, we want to go from the mass of A, which would be the magnesium hydroxide, to the volume of B, which is the hydrogen chloride. So we will want to go here. So we have to go from the mass of A to the moles of A, from moles of A to the moles of B using the mole ratio, and then from the moles of B to the volume of B. So let's use our unit conversion system. We want to start with the mass of A, as it shows here. So So we want to write 0.1 grams of magnesium hydroxide. We want to pass from grams of that to the moles of that, and we use the molar mass for that, which in this case is 58.33 grams of magnesium hydroxide, and that will represent 1 mole of magnesium hydroxide. So let's go back to our mole diagram. We have the moles of it, so now we want to go from moles of A to moles of B. We're doing this part. And I'm going to continue this in here. So we know from the equation, let's go back to the equation, that we have 1 mole of magnesium hydroxide and 2 moles of hydrogen chloride. So that means that we'll write that factor. So 1 mole of magnesium hydroxide for every 2 moles of hydrogen chloride. Now we have the moles of B. So we just want to go from moles of B to the gas, or not the gas, the volume. And for that we use our 0.10 molar. So we're going to say that for hydrogen chloride, 0.10 moles of hydrogen chloride, there is going to be 1 liter of hydrogen chloride, right? That is using our molar conversion, the molarity they gave us. But you want your answer in milliliters, so you go from 1 liter to milliliters, which is just 1,000 milliliters. And let's check our units. Liters go with liters, moles with moles, this moles with this moles, this gram with this grams. So our units are fine. We just have to multiply the numbers and we'll get the result. And I got 34 milliliters of hydrogen chloride. So for stoichiometry problems, you will want to use all your data and the molarity as a unit conversion factor, like I did in here. So remember, the number of moles is what changes, not the number of liters. You see that there's only 1 liter here, but the number they gave you, the 0.10 molar, represents the number of moles per 1 liter. And well, that's it.